Yeah, Professor, are you able to hear us?
Okay.
Yeah, great.
When say
Yeah.
me the start.
Yeah, I'll tell you, Professor. Few minutes, Professor.
Okay, thanks.
Yeah.
அது யூடியூப் லைட் க்ளோஸ் பண்ணிடுங்க. க்ளோஸ் பண்ணல, வால்யூம் வேணா கம்மி பண்ணணும் அதுல. மினிமைஸ் பண்ணுங்க. யூடியூப் வால்யூம் க்ளோஸ் பண்ணிடுங்க. க்ளோஸ் பண்ணிடுங்க. தெரியாதுன்னு. அவ்வளவுதான். அவருக்கு தெரியாதாமா நீ சொல்ற. யூடியூப்ல இருக்குதா? இன்ட்ரோடியூஸ் பண்றியா? நான் 58 பேர் தான் இருக்காங்க. ரொம்ப சொத்தப்படுறோம்.
இல்லை நான் பார்ட்டிசிபேட் பண்ண ஸ்டார்ட் இல்லை அவங்களே பண்ண போதும். ஸ்டடீஸை யூடியூப் லைவ் செக் பண்ணிக்கோங்க.
லைவ்ல தான் சார் இருக்கு.
ஓகேப்பா, ஓகே. ஒரு 100 இருந்தால் கூட பண்ணிடலாம் இருக்குங்க. The professor, participants are joining, Professor. We'll start in another 2 minutes, Professor. வேற இருக்க கோர்ஸ் கொடுக்கணும்.
Ma lo devo tenere sul tavolo. Vedi se tutti colleghi.
Yeah, Professor.
Okay.
Yeah, are you able to hear us, Professor?
Okay.
Yeah,
You can hear me perfectly.
Yeah.
Can you
Yeah.
hear me? Okay.
Yeah, I'm also able to hear you, Professor. We have already having 75 plus participants. Okay, others will be joining us shortly, Professor.
Okay,
We'll start the session, Professor. Yeah, very good afternoon, everyone present here, joined for day 5 of this international webinar. And before we start the session, let me give a small introduction to our expert today. He's Professor Giuseppe Paris. Okay, Professor has completed MS in Sofia University, Rome, Italy in 1972. And Professor is a full professor of electrical power system in Sapienza University between 1972 to 2017. And the professor has authored more than 360 papers. And the professor is a life fellow member of IEEE and from 2015, and he is also from fellow member from 2010. And the professor is R8 IAS area chapter chairman, and professor is IAS associate member to the governor board of Society of Social Impact of Technology, SSIT. Professor is IAS distinguished lecturer between 2019 to 2021, and he is also a president Rome section of AEIT, Italian Association of Electrical Electronics Automation Information Communication Technology. With a warm welcome, okay, I would like to request our beloved professor to start the session. Please, Professor.
Thank you very much for this invitation. I am honored to participate to this seminar, and I am displeased to not be personally present in with you. But let's go to make this overview on the IC protection against electric shock. Moment. Okay. Before to start the presentation, let me make a very short presentation of the dissemination of standards in the world. And essentially, in America, there are the Underwriter Laboratory and the National Fire Protection Association, and in other the world is a very important organization of the IEC, International Electrotechnical Commission, that has also the organization in all the continents. So in Europe, the IEC is organized with the CINELEC. And in Asia, there is the ICAPRC. In Australia, there are Standards Australia. And in America, there is the CANINA. Let me show how is organized in the European continent. So we have the Intercontinental IC and the CINELEC organize the conversion of the standard in European approach. And also in all the nations of the European Union, each country is organized with the national standard that follow the IC. So in Italy, there is the J, in Germany, there is the VDA, in the United Kingdom, there is the British standard, in France, there is the Normalisation Française, and in the same manner, in all the other nations of the European Union. So we have to discuss of another view on the IC protection against electric shock. So in North America, the discussion of the protection against electric shock is made with the National Fire Protection Association, NFPA 70A, and in European IC approach, there is the standard IC 6364. So we have to discuss over the direct contact and indirect contact. The protection against direct contact is not yet used by the IC approach, but IC approach discuss and present the protection under normal condition. that is provided by basic protective provision. So the direct contact has to not be cannot happen. So has to be always avoided. So the IC speak about the basic protective provision. Indirect contact is permitted only for condition of fault. It's not possible to have the touch voltage. Is permitted, is admissible obviously only in fault condition. So the indirect contact now in the IEC standard approach is discussed as protection under single fault conditions that is provided by fault protective provisions. So let me show in a case under single fault conditions of indirect contact. There is the figure, the photo, show a person that have a contact between a dishwasher and extraneous conductive part that is a water pipe. So what is defined extraneous conductive part? A conductive part liable to introduce an earth potential part such as non-insulated floors or walls, metal framework of buildings, metal conduits, and pipework for water, gas, heating, compressed air. Exposed conductive part are conductive part of equipment as a dishwasher, which can be touched and which may become alive under fault condition. Another important definition is the protective conductor, PE, that is generally a conductor with green-yellow insulation, used for connecting together any of the following parts: exposed conductive part, extraneous conductive part, the main earthing terminal, the neutral point of the secondary transformer low voltage, and this conductor effectively is green in India, United States, Canada, and in Japan. IC protection is very important to give other very important definition. And so it's important to highlight how the IC differentiates between the protective earth connection requirement of the devices. So exist class 1 appliances that must have their chassis exposed conductive part connected to electrical earth, such as washing machine and a cement mixer, how is shown in the slide. Class 2 or double insulated electrical appliances that are designed in such a way that it does not require a safety connection to electrical earth or ground. I have to say in this presentation, I use ground like in North America or earth like in IC approach. Class 0 are appliances that have no protective earth connection. This distinction between class 1 and class 2 is very important at the end of the presentation when we discuss of the risk evaluation of the touch voltage. Let us consider also the probability K of to touch electric appliance in a normal situation. So class 1 of devices, fixed or mobile appliance, such as washing machine and cement mixer, the probability to touch is very short during all the 24 hours of a day. Differently, the class 2 portable appliances that need to be held in hand during operation, obviously the contact, the key is equal to 1. Now, if a touch voltage is applied between 2 points of the human body, the body itself is crossed by a current. This current is a danger. It's not the voltage the problem. The problem is the consequence if a current crosses in our body. So it is very important to note that opponents, the resistance impedance of the human body varies, is not constant. It varies with the current and with the general condition of the organism. So in IC suggests a conventional value of the body resistance. And so for low voltage, apply the curve that present the statistic values that the human body not exceed the 5% of the average population is no lower than 1 kilo ohm for the normally used 200 voltage range of the low voltage appliances. So for current higher than 25 milliamps, there are different effects of tetanization, respiratory block, ventricular fibrillation, severe burns with that of the individual. An actual danger exists for the operator, yes, when? Only if the equipment is powered, obviously, at line to earth voltage U0. Another condition, the value of the touch voltage is higher than the admissible maximum value. Obviously, this is a conventional approach. And if a current can circulate in the human body because it's not normally happens electric shock if I touch a hot conductor, but we are sure that the current can circulate, is sure that the conductor is hot, is sure that the voltage is very high. And so let me show in this figure the conventional curves that the IC approach adopt. The higher curve is for high voltage appliance. The medium curve is for low voltage appliance, and the minimum curve is for very important special application like surgery or agricultural appliances. Let's consider that for the admissible value are changing with the voltage, and the permanent value that are considered conventionally admissible are 8 voltage, 50 voltage, 25 voltage for the different appliance, and for duration higher than 5 seconds or 10 seconds for high voltage. This variation, this vector, are very important in the following we discuss in the after. An electrical shock exists for the operator only if the appliance is connected. Appear obvious, but this is the first rule for a safe touch. Don't touch appliance if are connected. If it's possible to avoid to touch appliance connected to the grid, to the supply, it's possible. If it's possible to avoid, it's better to avoid. Disconnect before. So the current, effectively, can current circulate in the human body? In the circulation is negligible generally if the neutral point is not connected to the ground. And so for isolated system, normally the current expected, the prospective value is negligible in the body. But if the system is connected to the ground or to the earth, that is, the neutral point is connected to the earth, the circulation is surely active. So you have to expect a danger. For this reason, the importance of the condition of the neutral point, the IC type of earthing system is a very important definition. So the IC approach introduced TT system, TN system, IT system. So the first letter T or I is for system respectively solidly grounded, terre, ground, earth. In French, Italian is terre, so T, or ungrounded, isolated, so T or I, terre, grounded or ungrounded. The second letter, N or T, is for the connection of the exposed conductive part respectively to the same ground point of the supplying power system or to an independent ground electrode. I will show in the next better in the next slide. So let me show the case of the TT system. One time, an American technical people asked me why TT, why TN? TT system, the use of TN system or TT system is conditioned by the property of the high low voltage transformer. So in a power system supplied by an utility transformer, TT system can be erected only. It's mandatory to adopt TT system. TT system, the exposed conductive part of this washing machine has to be connected to a local ground system. So in the TN system, in a power system supplied by a proper transformer, the TN system is recommended for low voltage equipment. TN system is a common grounding system between low voltage and high voltage equipment. Due to the close proximity of equipment, it is not possible to separate the grounding system of high voltage and the low voltage. So the transformer, you can see in the slide, the transformer high voltage, low voltage, the neutral point, it is connected to a local ground system that is common to the low voltage appliances. So all the connection to the ground converge on the same ground electrode. So the IC approach introduced the concept, the definition of a global earthing system is an equivalent grounding system created by the interconnection of local grounding systems that ensures no dangerous touch voltages. Typical example of a global grounding system are in city centers, urban and industrial areas. Current can circulate in the human body. Yes, in TT system, we have, if a person touch a knot point or an exposed conductive part in fault condition, there is a circulation. The current circulate between the local grounding system and the ground system of the transformer substation of the utility. In the second figure, it's possible to see how the circulation in TN system is more simple, is more easy, because the exposed conductive part is connected to the same ground electrode of the neutral point. For this reason, the name Tn, because N is for exposed conductive part that are connected to the same electrode of the neutral point. So, this system, to arrive to understand the standard and the safe condition, conventional safe conditions of the IC approach, I have to present this following slides. And so we put attention how we run a TT system, a fault current path during a ground fault on the low voltage side. What is the way? The way is a circulation among the two resistance of the ground electrode. And we have to note that if I consider the loop, the impedance of the complete ground fault circuit, the impedance are localized in the two resistance of the ground electrode. And so, generally, the ground electrode of the utility present a very low resistance in comparison to the local resistance of the user, the normal user. And so, the impedance, the complete impedance at the end is practically equal to the resistance, can be assumed equal to the resistance of the local ground electrode of the user. And let me show the normal value or conventional value that we can assume for the components of the impedance of the circuits. We have to note that the impedance are the line, impedance is the connection to ground or the exposed conductive part, impedance are the two resistance of the ground electrodes. The impedance of the transformer is very, very negligible in comparison. Let me make this consideration that the line, the impedance of the line is very low, is surely normally lower than 0.1 ohm. In comparison to the local resistance that can assume a value of more than higher than 10 ohm, is conventionally is an example. And the resistance of the utility ground electrode is lower than 10 ohm. And so we have to consider that the touch voltage, if I touch an exposed conductive part conventionally, and for safety cautious approach, I can consider that the touch voltage assume practically the same value of the line to earth voltage. And so we can consider that if the touch voltage, the line to earth voltage is 230 voltage, the touch voltage is about the same value. In Europe, we use normally, I know also in India, there is the value low voltage is very frequent, 200, about 200 volt. And so the touch voltage in TT system, the touch voltage assume the same value. We have to consider that if we consider 10 ohms as reference value for this complete impedance, the value of the current is relatively low because is in the example is about 20 amps. And so we can see that it is lower than the TN system. Go to discuss over the TN system. In TN system, the ground electrode, when there is a fault on the exposed conductive part, the current don't interest generally the ground electrode, but the current remain, if there is a fault, remain in the system. And so the path during a fault, we have essentially the impedance of the transformer, the impedance of the line to the line of the circuit, and the impedance of the PE, protective conductor. And we generally, the IC approach, consider in the terminal circuit that the impedance of the line and the impedance of the protective conductor has to be dimensioned inside in the same way. And so we can consider that the impedance of complete circuit is equal to the sum of the impedance of the line, impedance of the conductive protective conductor. And so, considering that is equal, we can say that the impedance of the protective conductor is half value of the complete impedance of the fault. And so, go to consider the same value of reference of the circuit low voltage in condition of a fault. We have a value of lower than 0.1 ohm for the line, the same value for the protective conductor. And so we, in this case, if we assume to have 200 volt of the voltage of the line to earth, we can have that the touch voltage assume half value over the line of the voltage to line. And so if I have 200 volt, the touch voltage can be conventionally assumed an half value of 100 voltage. And differently from TT system, in this case, considering that in the TT system we have considered about 10 ohms. In this case, the impedance is 0.2 or lower than 0.2 ohms. And so the current of the fault current assume a very high value of the order of hundreds of amps, or in this case 1,500 amps. These are very important considerations. So, after the short presentation with definition and considerations, now we have to present of the core of the presentation, that is the protection measures against electric shock. The measure of the very generally important measures are the automatic disconnection of a supply, or the double or reinforced insulation, that is adopt class 2 equipment, electrical separation, extra low voltage. Use very low voltage is a way to apply safety, but obviously can be used only for very special appliances. So the webinar discuss mostly about the fault protective measure of the automatic disconnection of a supply against faults. This protective measure, we have to consider that is an active protection. In fact, in IC approach, the protective measure, the basic protection passive is provided by basic insulation of light parts by barriers or enclosures. That is, direct contact is not possible. So to avoid the direct contact is necessary provide very basic insulation of live parts. So to have a double insulation of a conductor. If I can touch a conductor, this conductor has to be double insulated. If the conductor is protected in the walls or in a duct, can be no used a double insulation. But if I can touch direct, is necessary to have this basic protection. Has to be avoided in a passive way, the direct contact. Contact, indirect contact is admissible, is prospected, but only in fault condition. And so the fault protection active way is provided by protective grounding, equipotential bonding, and automatic disconnection in case of ground fault. That is, if we have an equipment, and this equipment is class 1, that has to be connected to ground, to earth, it's important to organize the grounding connection and to adopt an automatic protected device that has to be organized to trip correctly if there is a fault. And so, basic protection against electric shock for direct contact, according to IC, is based on passive measures, such as double insulation of barriers, obstacles, or containers with a protection level IP of at least IPXXB. XXB is that the thing does not can touch active parts. We have the EP20. If 20, the thing cannot go inside the device. IPXXB, the finger does not can go inside the device but cannot touch active parts. In internet, you can find the definition of IP and the significance of the first letter and the second letter. Okay, or first number, second number. Or we can say that the first number is for the solid element, solid particle, and the second number is for liquid part. So, protection by automatic supply disconnection require the protective grounding and the automatic disconnection in case of earth fault. So, protective grounding, equipotential bonding. So, simultaneously accessible exposed conductive parts and extraneous conductive parts must be connected to the same means of grounding. So is defined the main equipotential bonding system. Additional interconnection of exposed conductive parts, metallic parts of the building structure, and other metal pipe work are recommended in TN system and in local space, like the floors, different floors, local room as surgery or other kinds of rooms. So are supplementary equipotential bonding. Let me show, it's very important, consider the time current characteristic curves. So, can listen? Okay. So the curves are very important to consider. So we can see the circuit breaker curves that you have to note the tripping current are for high value of current, current higher than the rate, the nominal value of the current of the circuit protected device. So you have to note for low value of the current are very important the ground fault circuit interrupter or residual protected device. is very important to use for low value of the fault current. Arc fault circuit interrupter are particular protected device for the arc fault. So, considering that the ground fault currents have, in general, higher values in TNS system than in a TT system, in a TNS system, the use of the overcurrent protected devices could be sufficient because the current in the slide we show 1,500 amps. A overcurrent protected device can protect a ground fault. But whereas in a TT system, the use of a residual current protected device is necessary because the current assumes low value. In the example, we show about 20 amps. Basic protective provision. In TT system and TN system, the residual current protected device are mandatory for IC approach because consider this active protection as a basic protective provision, also additional. The basic protection has to be always passive. The requirement to adopt in a way mandatory of a residual current protected device with the value of 30 milliamps is only for an additional protection. And this adoption is mandatory for socket outlets with a rated current not exceeding 20 amps that are for use by ordinary person and are intended for general use. It's mandatory also for mobile equipment with a current rating not exceeding 32 amps for use outdoors. Let me show how is only additional the protection of ground fault circuit interrupter in case of absence of a protected grounding. We know that in any case, in many building of a private building does not exist the grounding electrode. And so if you use the ground fault circuit interrupter, what happens? If there is a fault, there is no problem if you don't touch. But you can see that if you touch the exposed conductive part, the current can cross in your body and the ground fault circuit interrupter, if the current is higher than 15 milliamps, and so higher than 30 amp is the ground fault circuit interrupter open, but the ground fault circuit interrupter detects the failure only when the operator touch the hot part. And so if you touch, if the current go inside your body, perhaps you can be live or perhaps you can die. And so the ground fault circuit interrupter is an addition, can help to save, but don't guarantee your life. In the other condition, if the exposed conductive part, the dishwasher, is connected by the grounding conductor and there is the ground electrode, when happen a fault, the current immediately circulate inside the circuit. And so the ground fault circuit interrupter trip, and trip without if you touch or not touch. It's better if you don't touch. It's not necessary that you can have to touch because the ground fault circuit activate the ground fault circuit interrupter to trip. So the IT system to have the neutral does not connect to ground is surely the more safe, the safer condition, but cannot be adopted in general because at the second fault, the problem, the system don't run well better, and the second fault, the system become TT or TN system. So in general, only for special application will be used the IT system. A very special application is a surgery. And so in the surgery, we have ITM system, but it's necessary to separate, is necessary a transformer, insulating transformer that separate the neutral connected in the general system, low voltage, in this local system, the insulating transformer guarantee that the neutral point is not connected, but an insulation controller has to control that the insulation remain correctly in operation. So at this moment, we can introduce the condition proposed, suggested, required by IC approach. And so we have to consider, I say to my student, please adopt 3 colors when you write the equation. So you use the black color for the faulting electrical equipment and the supplying part of the power system. Please consider green the condition for a safe life of the operator, and consider in the red color the protected devices. So we have to consider in black color the current. So the current is dependent by the system. And so if happen a fault, if the system is TT, is TN, is IT, appear a current, appear negligible for IT system, is a low value for TT system, higher value for TN system. So we can consider the color IT current is the fault current, black value. The operator, what is important for the operator, that if the operator touch has to be always guaranteed that conventionally that the touch voltage can assume only admissible value. And so the value, the green value is connected to the safe voltage, a safe condition. The red value, the current, is the typical current of a circuit breaker, has to be the circuit protective device has to detect the fault. And so in the last line, we show the condition suggested by the IC approach. You can see IA in the time A has to be lower than the fault current. And so the fault current is the current of the system if in condition when the exposed conductive part is faulted. And so the typical current has to be lower than the current fault, but the trip has to operate in a time lower or equal to the admissible value. And so we can consider what are the admissible value. So the protected device, if happen a current, in how many seconds or fraction or rate of seconds has to be operate. So now it's important to remember the condition. We said that in TN system, generally, we have to, is expected if the voltage U0 is the voltage line to earth, we have to prospect that the touch voltage assume half value. And so if I consider, for instance, the value 200 volt, you can see that 200 volt half value is about 100 volt. If I go on the curve of the low voltage, the medium curve, I can find that for half value 100 volt, the time admissible at 0.4 seconds. And so if the standard IC standard say, if please look to the voltage of the line to the earth, assume that the time, if you go to control on the curve, the half in correspondence of the half value of the U0, you find the time. And so you can find in the IC standard a table where U is mysterious. Why? When in correspondence of the voltage of the line to earth, you find the time. But this time you can find on this curve, you can find exactly that if the voltage is 230, you find that the admissible time so the time TA has to be no higher than 0.4 seconds. That is in correspondence of the value of the alpha value over the line to earth. So in TT system, we show that in TT system, the touch voltage, the prospected, the safe, the cautious value of the touch voltage has to be assumed equal or near equal to the voltage line to earth. And so about near to in correspondence to the touch voltage line equal to line to earth of 200 volt, you can find 0.2 seconds. And so the IC standard suggests to the tripping of the circuit breaker has to be in time lower than 0 or equal to 0.2 seconds. So TT system is alpha value of touch voltage, alpha value over the voltage line to earth. In TT system is about equal. So this is the secret to understand how are the requirements of the IC approach of the protection. And so conventionally, I show in precedence that the touch voltage limit permitted to be maintained indefinitely, that is more than 5 seconds and 10 seconds, are 50 voltage, 25 voltage for special condition, 80 voltage for high voltage applications. So we discuss about the importance of the circuit breaker for TN system, but residual ground fault circuit interrupter are always mandatory for additional protection, also like basic protection. Okay, we have discussed, but when it's not possible to respect the condition, the requirement, the general requirement, how is possible to operate? So it's possible to evaluate if the risk is acceptable. Also, if it not respected the condition, the risk is acceptable. If yes, it can be permitted, don't satisfy the condition, or differently is always possible to provide local bonding that are defined as supplementary equipotential bonding. How is important local supplementary equipotential bonding, especially in TN system? You can understand that if the exposed conductive part is connected to the main grounding electrode, but locally in a local panel, there is the connection of the all the connected to ground components like exposed conductive part and extraneous conductive part are connected also locally. The impedance of the protective conductor is subdivided in fraction, in rates, and so the voltage, the touch voltage is reduced, the local touch voltage, and so the safe condition are enhanced. So let me show how. If I have a washing machine connected to the ground, and if there are no supplementary equipotential bonding, you can see that this connection go direct to the earthing terminal of the local ground electrode. When we use supplementary equipotential bond, you can see that the local panel, the connection to the main ground conductor, if you have the metallic element on the floor, and so other extraneous conductive part are locally connected to the ground, you can see that the impedance of the back of the current on the protective conductor when go down, but we have an assumption of a part of the value is reduced in the presence to the floor, and so this person touch a voltage reduced in comparison to the value, and so we don't have if there is a TN system, I don't have half value of the voltage line to earth, but I reduce the part. And so is more reduced. If I consider 100 volt, I have a part can be 30 volt, 40 volt in comparison to 100 prospective value of the touch voltage. So at the end, we have to do a risk analysis by time windows intersection for analyzing and assessing the electric hazard of a person touching a faulted exposed conductive part. It is suggested an approach in analogy with the study of the collisions of masses and the intersection theory. So is when happen a collision because two masses have go in the same point in the same time. And so when we have to consider a fault event and an active protection constitute respectively the action of a hazard and the reaction to stop it. So the fault event cause origin and hazard, the protective device has to stop it immediately if it's possible. The combination characterizes a risk exposure window. So the contact time can be simultaneous to the exposure or to the window or not. So if there is simultaneous, we have a collision. But if it's not simultaneous, I have only a contact. if I touch the washing machine after the fault, I have a contact. It's permitted to touch my washing machine. The problem if I touch during the window or the exposure of the fault. And so is very important the probability to touch. So for fixed and mobile equipment, the class 1 is permitted because the washing machine I don't touch every time, but for the class, the portable component like an earphone or a drill is very important to have a double a class 2. Don't have the ground connection and don't have the active protection because the contact is a guarantee, is necessary to during the use to have on the end, on proper end. And so to avoid the simultaneous problem of the contact during the exposure, the risk exposure, is better, is mandatory, is recommended to adopt class 2 of the portable component. So at the end, the protection practice against the electric shock points to solve each collision by an active measure. The fault opens a time window of risk. The protection has to close it promptly. The protection has to limit the fault exposure persistence in a conventional time, 5 seconds or 1 second for TT system, probable protection as general objective. Thank you for your attention. Thank you very much.
Thank you, Professor.
Thanks. Hello. I hope all us to be listened well.
Yes, sir. Yes, sir.
Okay.
Yes, sir. So now I
I will
request.
send.
Yes,
I
sir.
will send obviously the presentation. I will send you the
Sure, sir,
copy
sure, sir.
of my presentation. Okay.
Sure, sir. Sure, sir. Thank you, sir. Now I request the participants to ask questions, or else you can even share it on the chat box.
See, okay. Real. Okay.
Yes, sir.
There is some question. Is there?
Professor, still now there is no question in the
Okay.
chat box, sir. So we'll wait for some more time, sir. Another few minutes, sir. If any question is there, I'll let you know, sir.
Okay. So if you also if you send me email, if there is some question, I will be
Sure, sir. Sure,
enjoyed
sir.
to. Okay.
sir.
So
Sure, sir.
okay. So see, we want to start. I will send immediately a PDF of my presentation.
Yes, sir.
Okay.
Yes, sir.
Okay. It's a very pity don't have participated to Pondicherry. I saw it's very nice to visit the temple of Manakula
Vinayagar, sir. Vinayagar.
I have an exercise
Yes, sir.
I got the pronunciation. Manakula,
Yes, sir.
Manakula, Vinayagar.
Yes, sir.
Okay.
Yes, sir. It is a God's name,
No.
sir. In our country. In our country, it's a God's name, sir.
Okay.
Yes,
So,
sir.
but I visited New Delhi. I visited Mumbai, New Delhi in 2000, and Mumbai in 2003. Oh, okay. So I know it.
Yes, sir.
I like. It's a mystic. Very nice country. Okay.
Thank you, sir. Thank you. Thank you so much, sir.
Okay. So
Thank you, sir.
Okay, we
Okay,
can
Professor.
start.
Yes, sir. If any question is there, I will mail you, sir.
Okay, I
Yes,
will
sir.
say,
Yes, sir.
thank you. So,
Thank you
nice
so
to
much,
meet
sir.
you.
Thank you so
Nice
much,
to
sir.
meet you. No, thank you
Yes,
for
sir.
you.
Thank you, sir. Thank you so much,
Thank
sir.
you. Bye.
மேடம் பெண்ணில்லை மேம் சாரி டிஸ்டர்ப் பண்ணிட்டேன் நானும் கவனிக்கிறேன்